quantum computers. We've all heard about them in headlines, how they're going to break online privacy or crack your encryption. But you might be wondering, what actually is a quantum computer? What actually is a quantum computer? Okay, so we know that normal or classical computers operate using bits, which have a defined state of 1 or 0. Quantum computers use qubits, which are in any proportion of both 1 and 0. Wait, what? Consider the spin of an electron, something commonly used as a qubit. Its spin can be either up or down, but before it's measured, it's in a combination of both being spin up and spin down at the same time. This is called superposition, and, for later reference, can be described in a wave function. This property allows for qubits to represent much more information than their classical counterparts. For example, 2 classical bits have 4 possible combinations, but can only be in one definite state at one time. Qubits can be in a superposition of all 4 possible states at the same time. In other words, n number of qubits can encode the equivalent of 2 to the n bits of information. But won't the qubits take on a single value when measured? That's exactly right, but this is where another quantum property comes into play: interference. Remember when I mentioned earlier that superposition can be described in wave functions? Well, multiple wave functions can interact with each other, altering the state of quantum objects while still in superposition. This allows for all configurations of qubits to be operated on at the same time. These advantages make quantum computers excellent at things classical computers struggle with today. For example, classical computers struggle to find the prime factors of large numbers, but quantum computers don't. This allows them to break cryptography. Personally, my favorite application of quantum computing is for molecular simulations. Funnily enough, computing quantum physics with, quantum physics is pretty effective. This opens many new possibilities for material science, pharmaceutical development, and many more fields. In conclusion, quantum computing is an exciting new field, and I'm looking forward to the new possibilities it will bring to the world of technology.